Yes. So now we will be dealing with another algorithm, which is k nearest neighbors. So what does this k nearest neighbors means? So here in this state, in this k nearest neighbors, the classification is based on the near neighbors, neighbors which are near. So how is it possible? How can the algorithm classifies between the near people? Everything will be dealt in this session. Okay, so let's suppose we have two inputs. Okay, so let's take fruits. Okay, so in that fruits I have the weight of a fruit and the size of fruit in centimeters. Okay, so whenever I plot those two variables on a graph, all the fruits which are of centimeters, which are of size 5 to 6 centimeters and weight of 10 grams to 20 grams lie here. Let's suppose another fruits which are of 15 to 25 10 centimeters or so, and then the weight is like about 50 grams or 60 grams, then those are plotted over here. Okay, now suddenly a fruit of some value of x grams and some value of y gram came into the picture. Then how does the algorithm classify whether this belongs to this class or this class? This is what our k nearest neighbors do. So I'll also tell this with an example. Okay, so now this is a new data point. Now what happens is, this new data point will be calculating, the algorithm will be calculating the distance of all the remaining points in the graph using some sort of distance measurements. So one is Euclidean distance. So you would have seen this Euclidean distance formula in our inter as well as in our degree, in our engineering, right? So x2 minus x1 whole square plus y2 minus y1 whole square under root. This is one of the distance that is used for calculating the nearest neighbors. And another one is Manhattan. So the formula of Manhattan is k sigma y I is equal to 1 xi minus yi. And then you have Minkowski distance. So the formula of Minkowski distance is this one. All right. So these are all the values these are all the formulas that are used for calculating the distance. All right. So here, this new data point calculates all the distances of all the points, and then I will consider the nearest neighbors. K is nothing but the nearest neighbors as 5. So it will see what are all the nearest neighbors which are over here. So when you find all these things, so here these are 3 nearest neighbors, and here you have 2 nearest neighbors. So towards this, if you see this, what is the majority of the points lying towards? It's towards right. So this new data point is considered as the red point because it is very near to the red points. So in KNN, what happens is the distance will be calculated, and again the nearest distances are taken. So whichever side there are majority of the neighbors lying, then that side this new data point will be considered. So after that, the model will be ready. So first in this KNN, you have to choose the number of neighbors, and then you have to take the k nearest neighbors of the data point according to the Euclidean distance. It could be any distance, Euclidean or Manhattan or anything. Among the k neighbors, count the number of data points in each category and assign a new data point in the category where you counted the most neighbors. Then your model is ready. So here the KNN is considered as lazy algorithm because it has to calculate all the distances in the data set, all the distances of all the points in the data set, right? So it will take time. So training time is more than testing time for the k nearest neighbor. So let's take a small example and showcase how this distance calculation is possible. All right, guys. So let's take a small example. All right, guys. So once I'll tell you the examples, then I'll show you these steps again, guys. Okay. Fine. So now let's suppose I have weight, size, and fruit. Okay. So here weight is 20 grams. Size is like 50 millimeters. And I consider it as apple, let's suppose. Okay. Now, weight is 25 grams. Size is 60 millimeter. I consider it as apple, let's suppose. Now, I have 10 grams or else let's say it has 10 centimeters or something like that. Let's suppose case, not 10, 10 centimeters, 15 centimeters. Just it's just for suppose, it's just for assumption. So it is 10 grams, 2 centimeters. This is lemon. Okay. Now again I have 15 grams, 4 centimeters. This is also lemon. I have 30 grams, 12 centimeters. I say it as apple. Next, 35 grams, 10 centimeters. I say it as apple. Okay. Now again, it has just 15 grams or 12 grams, 3 centimeters, lemon. 10 grams or 11 grams, 2.5 centimeters. I say it as lemon. All right. So let's suppose this is the data set that I have. Now let's plot the graph. So on x-axis I have size and on y-axis I have weight. All right. So here we have as 2, 4, 6, 8, 10, 12, 15, 20, 25, 30, 35. Weight on x-axis and size on z-axis. 2, 4, 6, 8, 10, 12, 14, 16, let's suppose. So now let's plot the graph. So here it is, weight is 20 and size is 10 centimeters. Weight is 20, size is 10 centimeters. So this belongs to this group. Now, weight is 25, 15 centimeters. 25, 15 centimeters. Weight is 10, 2 centimeters. Weight is 15. Weight is 15, 4 centimeters. Weight is 30, 12 centimeters. Weight is 35, 10 centimeters. 12, 3 centimeters. 11, 2.5 centimeters. All right. So now the whole thing belongs to one group and these whole thing belongs to one group. Yes or no? Now a new data point came. A new data point of 15 centimeters and 15 grams and 4 centimeters. So 15 grams and 4 centimeters. Now, to which point this belongs to? For us, we can directly say that as the values are 4 and 12, this belongs to this point. But for an algorithm, there should be some sort of mathematical calculations, right? So now what happens? This will calculate the distance between these points and this point. This point and this point, 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 this point and this point. So you know the calculation of the Euclidean distance, right? x2 minus x1 whole square minus x1 whole square plus y2 minus y1 whole square under root, right? You know the formula. Now let's suppose the distance between this and the first point is, let's suppose it 10 centimeters. Distance between this and this point is 20 centimeters. Distance between this and this is 30 centimeters. This and this is 40 meters. All right. Now the point between this and this is 5 centimeters. This and this is 10 centimeters. This and this is 15 centimeters or else 12 centimeters. This and this is again 10 centimeters. Now tell me towards which side the distance is less. To which side the distance is less? So if you consider 5 points, this point is considered, this 5 centimeters point is considered, this point is considered, yes, this point is considered, this point is considered, this point is considered, and this point is considered. Now tell me to which side majority of points are lying. Tell me to which side majority of points are lying. It's down. So that means the point is considered as lemon. The new data point is considered as lemon. Understood, guys, how the KNN works? Did you understand how the KNN works?